Computer. Wonderful. Okay, very good. I think we should get started. So we're extremely happy to have Sabrina Amrouche here to talk to us today. So Sabrina actually comes from a physics background. I think did statistics and physics, and it's kind of a special moment where we have this sort of overlap between machine learning and physics, given that we've just had the Nobel Prize yesterday in physics. Controversial to some people. I think it's a pretty interesting recognition of very important work that's been going on. So Sabrina seems to wear a number of different hats, both working for ZYTLYN, if that's the correct pronunciation, and also AfriClimate AI. I found out about AfriClimate AI just a few weeks ago at the Indaba in Senegal, the deep learning Indaba in Senegal, and I thought it sounded like a really, really interesting initiative. Here at UCT, we have people working in machine learning and people working in different aspects of climate change, but we're trying to sort of foster more collaboration between the fields, and it seems like Sabrina's work and AfriClimate AI is doing precisely that. So with that, it's over to you. Thank you very much for being here to talk. Do you want to share your screen?
Yes, absolutely. Thank you so much for the introduction and thanks for the invitation. I'm very happy to be here. So today I'm going to talk about AfriClimate AI. It's really a community, but there will be a few items I'm going to go through as well. Feel free to interrupt me and ask questions because I think the goal is to interact a lot. Yeah, I don't think I need to introduce myself at this stage. Thank you for that. So we can dive right in. By the way, I'm really presenting on behalf of the whole team at AfriClimate AI. I'm going to tell you more about it, but we're around 9 people with diverse backgrounds. Yeah, and I'm lucky to be representing them today. So diving in right in with the first topic, which is climate. It's really the problem we're interested in. And I wanted to kick this off with a very interesting map that shows the worldwide distribution of ground-based weather radar sites. And this is from the WMO from 2019. So the maybe striking thing about it is Africa is almost completely, almost not even on the map, except for largely South Africa. So thank you for that. You're saving us a bit. And then the other thing is that not only there is a huge problem of data scarcity and not enough weather stations, but the numbers are actually declining, which is the alarming factor here. So you can see the trend here that due to several factors, mainly maintenance, but also lack of funding, we have way less stations today than we did 10 years ago or 20 years ago. And this is really a problem in climate because no data, you cannot really do much, whether it's on the climate or on the AI side. So the other axis is that weather forecasting models and climate models are doing better and better. So here you see the evolution of the forecast scale since 81 to 2013, and we have the northern hemisphere, southern hemisphere, and with different lead times. So basically, if every 10 years we're gaining few percent, like almost 10%, and like these look really, really good. So every 5 years now and then we're improving our forecast skill and getting more accurate at the weather prediction. So this is very good news, but yeah, I'm going to tell you why we should be worried about this rather than excited. So what I showed before is, like, you notice the x-axis, it stops at 2013. Machine learning was not yet having impact then, but this graph is more recent. So you can see the climate physical models here, and then the machine learning models, and basically the colors indicates the performance on different metrics. You have pressure, temperature, humidity, wind vector, and batteries on blue. And you can see, for example, for a model like this is a very famous state-of-the-art model called GraphCast. It's doing better than most the models that came before it, including climate and physical models. So the conclusion I think that everyone is agreeing with, whether in AI or in the climate sciences, is that AI is driving change and impact in weather forecasting, and this will likely be the default models used in the future. So like the last axis I wanted to quickly mention is that, so we talked about, yeah.
Sorry there, can I just ask a naive question if you go back to the
Please.
previous slide? So climatology there, the last one, what does that correspond to?
So I think these are the, like it's not the physics models, but the models that, like the very first models, like that's why it's all in red. So it's actually chronologically, it's climatology, physics models, and then ML models.
Okay.
So you can see it as, for example, ERA 5 forecast is a combination of physics models, but also observation and simulation. And it's exactly what preceded the machine learning model, and it's the foundation of them. But climatology is really like more like purely physics models that were relied upon before that.
Cool. Thank you.
Yeah, and I'm also, I am absolutely not a climate expert. I come from the AI background, but still, please don't hesitate to ask. I think there is a lot we can, like, we're trying to learn as we go. So the last axis I wanted to mention is the funding. Like we saw the declining number of stations, and we talked about climate as a problem, as an emergency, AI driving change, and I just wanted to share this. It shows the distribution, like the top 10 institutions receiving funding for climate research in Africa. You can see here, most of it is not coming to African institutions. Thank you, Kenya and South Africa, for putting us at least on the map, but that's a bit the idea. So I combined these three factors, and last year we were meeting at the Intaba and we started talking about these things, and we really felt the need to have a climate and AI community for exactly this reason. So there is not enough data, AI models are being built and creating revolutions, but nowhere near Africa, and the funding is not not in Africa, because you can very well build a model like here where I'm sitting in Geneva, but as long as you don't have observation data, regional patterns, and so on, it's not going to be in accurate models. So that's really the why I'm here today, like these three axes. And that discussion happened actually last year at the Indaba. It was in Accra. Randani, our co-founder, was giving a talk, and we started talking about the data scarcity issue and how we are in need of AI and climate models in Africa. So we thought, yeah, we should absolutely have a community around AI and climate in Africa. So very briefly, this picture actually is from Dakar, from the last Indaba, just a month ago, a bit more than a month ago. So on the right, there's the core team, 8 of the 9 founding members. We have very diverse backgrounds. For example, I come from, like Jonathan, you mentioned physics, but also I'm in industry. We have Google researchers, academics, PhD students, so it's really diverse in climate and AI, in the intersection of the two. And we're really trying to address different aspects that I'm going to be mentioning. This is a bit the like an overview of the community at large. So there's the core team, but there are also a number of people who joined that since last year already. We're over 100 people, like actually almost 200 on Slack, but like 100 that we know and that contribute a bit from 24 countries with diverse interests. So some are all about weather forecasting, others are about hydrology, disaster management, so really diverse interest. And we have we're really trying to do work on 2 different axes. The first one is capacity building. So all what you see on this slide actually happened between I don't want to say last year, because last year we were created, it was very slow, but we really started around February. So between February and today, We organized seminars, workshops, we're in conferences. We had a position paper out. We had also a YouTube channel with monthly seminars. And we built tutorials that you can find on our GitHub page. So these tutorials are really using, so we take these global forecasting models and we were able to secure some observation data and we did some benchmarking on them. So you can see, for example, the performance of something like GraphCast as opposed to the observation data. And the second thing is we're also having partners to help us that are maybe experts in climate, just like TAMO and ENACT. Maybe you don't know TAMO. TAMO is the Trans-African Hydrological Meteorological Organization. They have over 600 weather stations, like these big stations that record data all over Africa, mostly in the good portion of Africa. Yeah. Should do something about the north, but yeah. And for example, 200 of these stations were stationed in schools, high schools, and universities, so that the students learn more about what climate data is, why is it important, and so on. So we're actively working on them. On data-related projects, but also on capacity building, such as like creating awareness around the stations and the school. ENAX is another partner, so we're providing completely different type of data. They also have very interesting coverage that we're working on. And some of our other partners include AIMS, Rwanda, UNU, with whom we're planning a policy workshop next year, and also Climate Change AI. Dev Data is an example of a startup that we started working with recently. They're interested in plant disease, and we believe that startups are key in deployment. So if we build something, for example, we're able to have a model that does a bit better in Kenya, we would need local actors to help us deploy these models and really provide value to the farmers. So we're trying to cover all these axes: government, startups, innovation, and education. And then around the projects where we actually write code or papers. So the first one is around policy briefs. We have this idea of building a roadmap for AI and climate science in Africa. We had the first version out. It was in the form of a position paper, and we're working on extending it with partners such as the Met agencies of different countries, like Ghana and I think Tanzania, where we started working with them. Another project is Engalia. It means to look in Swahili, and it's about creating a model and data verification platform. So it's a bit what I was mentioning before. You have global models that are more or less failing in Africa, and we want to have a systematic, rigorous evaluation of how and why, and basically put that out there. Another one is around operational remote sensing models. One of our team members is working on an open source tool called InstaGeo, and we believe it's going to be have a really nice impact on weather and decision making. And the last one, which is actually leading it, it's called AfriNet. So we had this idea of what if we buy low budget weather station and we provide them to members of the community, and so that you can collect data from your balcony and then just share this data and create an API over it and make it available for everyone. So the idea was really around capacity building, but the more we started talking about it, the more people got excited. They even wanted to buy their weather station. So it's becoming this whole new project with the APIs we see as really the first product. But imagine you have a free API where you can get data from that farm in Tanzania. You could use it and do your own benchmarking or even your own fine-tuning, and that could be a game changer for the community itself. So I think for today, I want to tell you a bit more about these two, mainly because that's where my expertise lies. But if you have other questions around the two other, I'm happy to answer. So the first one is AfriNet, and I think we're having a meeting about the cost of these stations and how hard it was to maintain them on the continent. And just thought, like, what if we just buy these small stations and we record simpler things like total precipitation, temperature, humidity, and we try to start there. And the cost was really good. Like they cost $150. So we started buying them from our own pocket. And the more we talked about it, the more people were excited. So the station you see here is actually was at our stand in Dakar. And right now we have 7 people involved in this project. We are struggling a bit with the shipping of the stations. So if any one of you is a shipping expert in the continent or knows someone, please get in touch. But the idea is that we started, I think we have 3 stations now and planning to deliver 5 or 6 more just for a small POC. And the idea is you deploy, like you install it in your balcony, garden, outside, wherever, rooftop, anywhere. It has access to the sky. And we started doing like a small API on top of it. And the idea is to have a dashboard where you would allow people to visualize a bit, okay, this person submitted this data, it's this temperature, from different corners of the continent. And of course, the longer term goal is that once you have the data, you can play a bit with it, try to do, for example, quality analysis on other data that's available, or even fine-tune models with the subsets of data. And the end game is obviously to get the community involved even more, maybe play a bit with machine learning models, and why not deploy fine-tuned versions of these large models like GraphCast? We've been actually one of the developers of these big models. The model is called GenCast, has agreed to join the community and is actually excited about the project. So we started discussing simple ways of maybe having an observation data channel in the model and fine-tuning it. And of course, the impact could be massive, as this could be deployed in farms, used by Met agencies or even government for disaster management. And really, the applications are endless. Yeah, so this is an example of this really just a Figma of how the dashboard is going to look like. And the idea is that you would have access to the weather data, and you could see, for example, like track the evolution. You have kind of a community activity where you see the people who asked questions, submitted their data, and we even thought about some sort of leaderboard and some sort of reward system for the community. So of course, all that is just to give more incentive to people to care about climate and gamify a bit this. So that was AfriNet. Moving to the more AI project, really. So Encaria is to benchmark the global weather forecasting models. What you see here in the image is from our tutorial at the Indaba. And what we did is we took data from TAMO. So TAMO was able to provide us with data from 9 stations in Kenya. And then we generated a forecast for these, and we compared how accurate the forecasting is with regard to the observation data. So this is actually, I believe, the first time this was done, because these forecasting models are trained on a data set called ERA5, which is a simulation of the past rather than the actual observation. So they take the observation, they take a climate model, and they build simulation of how the data is like. It's extremely accurate for Europe and North America, but not so much for the global South. So basically, if you have a model that says it has a 95% accuracy for Kenya, it just means that the data is not there, like it's very sparse. So we take observation data and then the forecast. This is really the benchmarking that can tell about the accuracy itself. So this is what Engaria is about. We have a team of 10 people working on it. We have different pillars on the project. First one is around the data. So there's this need to combine observation data that comes from stations with gridded data, satellite images, and the other axis is the performance and the metrics themselves. How would you evaluate these models? Is it an MSE? Like, do we care about extreme events? Is it regional? Is it national? Like all these questions we hope to answer. So this is really, in a nutshell, the Engadia project. And to give you an overview of the future plans, we try to have this graph that really summarizes every single thing we're doing. So a few of the things I mentioned are already here. For example, the AfriNet project, the TAMO weather station network and maintenance. So this is the school seminars I mentioned. And we have a bunch of workshops and summer schools that are planned for next year. Also, policy making workshops with the UNU. And of course, the end goal is to develop systems. So when you have these models that are fine-tuned with observation data, you enable things like early warning systems that these become actually useful on the continent. We also hope to build the tools to enable people to go even beyond that. So Engadia is planned to be a platform, open source, and people can extend it in the future. And we also have hackathons and innovation challenges planned. So the idea is to enable people to innovate. So maybe fund startups that could take these models and really deploy them or put them in a smartphone and so on. So this is really the idea. I think maybe I've been too fast, but this is really the content I have for you today. I hope if you have any questions, I can spend a bit more time on any of the slides.
Wonderful. Thank you very much indeed. Yeah, this I think is super interesting, and I really do recommend that people get involved. And maybe that's I guess one question is sort of what are the lowest hanging fruit in terms of getting people involved? What would you say to the audience here to do other than joining on this website? But yeah, what are sort of good first steps, do you think?
Okay. So of course, the first step is to join on the scan the QR code, fill in the form, so we get to know a bit about you. But I have this slide. I wasn't sure I wanted to share it, but since you asked, to give you a bit more insight on how these groups are formed, so you get to see who's doing what. So I only mentioned, put here the number of people involved in the projects. So we really need anyone with any set of skills, right? So if you're really good at writing grants, we definitely need that, because everything I mentioned we need money for. If you don't care about AI but really want to write blogs and we're a really good front end, we absolutely need that. Actually, it's the thing not a lot of people want to do. AfriNet is this low budget weather community stations. That's also a project you could join. So it really depends on what you want to do. And I think we have projects that are very, very diverse. Even the workshop and schools, some of them are with policy workers in mind. So it's about policy briefs and the state of things in Africa. Others are more addressed to students. And so I don't know if any of you had a specific question, but if you're interested to join, pretty sure we can have something that's of interest to you.
Awesome. Thank you. Are there any questions from anybody else? So I had another kind of naive question, and this is maybe a bit more about the details. So you're setting up these very local weather stations, modulo shipping issues. What's the relationship between what you can get from satellite data and what you get from these local stations? In the sense that what does one miss when you're just using satellite data? Is it just the locality issue?
Yeah, that's a really, really nice question. That's actually a real problem, especially if what we care about is the impact on the ground. So satellite data has a granularity. I think the best you could get is in kilometers. So it's like five by five. And that's really if you have the satellite there. The ERA 5 that has been used to train all these models is actually a 25-kilometer resolution. So it's really like a box, right? So it's if you have a 25 by 25 box and you have more or less one data point on it. Imagine you have different people in that region, and then it's not as accurate as if you have a weather station, for example, in the farm. So this is the key difference. Having even a low budget weather station that would allow you to have temperature, precipitation, and wind velocity and direction on a farm is already a game changer, because that's a one data point really on the area that you care about. So satellites are more like we usually refer to the end user. So if your end goal is to help a farmer better plan the watering of crops, then satellite is not the best fit. If your end goal is to plan a country policy on XYZ, yes, then satellite definitely is a good fit, because it's really on the larger scale.
Well, thank you.
Does that?
Yeah. That's spot on. Perfect. The other question I had was whether, so at the moment, sort of shipping is the issue. If people had, for instance, 3D printers and access to, relatively basic electronics, is there something that people could do sort of from a set of instructions in a kit, or is there something that really has to be sent out as a ready-made kit?
This is a brilliant question, and an idea I'm definitely going to relay to the more hackers in the team. Like right now, we don't have the skills to build those stations, or even to open them up and see how they work, but that's definitely along the lines where we want to go. We really want to lower the barrier in terms of who can provide data, or who can contribute to the community. And having something that you would build yourself is definitely a very good idea. I honestly don't have an answer on what it would take, but we're going to follow up on this one.
Yeah, it sort of feels like one could have a hackathon with a load of makers and electronics people to figure out like what's the cheapest way to build this yourself.
Yeah, absolutely. Actually, one of the ideas that came up from the team is like if I'm able to quantify how much it's raining, because these weather stations are really like cups, right? Like you kind of measure the rain over a certain period of time. And someone was saying, okay, if I just take a picture of some bucket, or like I want to contribute to the dashboard, but I don't have the tool. So pictures, for example, like just measuring with a bucket and sending to it. Like that's something we're actually allowing in the dashboard. Of course, we're not necessarily ready to use it, because processing this data, like making sure it's recent, it makes sense, could cost us a lot more than to actually buy the station. So, but we do want to allow this sort of contributions. Maybe at some point we would converge towards, a nicer path. Like, I don't know, like you would build a weather station from a bucket. That sounds like a very cool hack.
Awesome. Any questions from anybody else? I think we have Lavinia here from the ACDI. I don't know if anybody else is here from ACDI, if you have any questions or input.
Hi, thanks, Jonathan. No, I've just been listening in, new to this whole field, and really trying to get a sense for how we can use it as well. But Tesfaye is also here. I don't know if you have any questions, Tesfaye.
Thank you. I'm so fine so far. I think it's better to adopt it.
Sure.
And working. Thank you.
Sure. So I'm also going to be sharing this with the rest of the people at UCT who may be interested. Yeah. Any last questions or comments from anybody?
Yes, I have a question. So with the AfriNet, it's when people send in the data, is it basically the team, you guys, that basically check the quality of the data, not the people actually sending it?
So
yeah, that's just my question.
Thanks a lot. So the idea is really that we have weather stations that, so basically if you want to contribute, you would receive your weather station, you would install it, And then the station just needs Wi-Fi and electricity, and it would send the data to our data server, right? So essentially, from the user point of view, you don't have to do anything, no quality monitoring, nothing. The quality monitoring would be like a service on top of the data bucket, for example. So yeah, like the user, they just need to set it up, maybe clean it from time to time, which is also a game changer because cleaning a small station is much easier than these large ones. But for like the idea is that we make it as simple as possible, so that the station emits the data. You would only need to make sure it's plugged in and Wi-Fi is up. And the other idea that Jonathan was mentioning is that beyond that, if people want to contribute, but they cannot have a weather station, they cannot afford it, we cannot afford it. The idea is to let them submit whatever they want to submit for the sake of capacity building, really. So it's not for us to use that data, but just so there is a bit more awareness of, okay, what does it mean that there is this amount of precipitation? How does it compare to last year this time? Is it changing? Is it changing for me, but not for my friend like 100 kilometers from me? So it's really to allow this kind of discussion, but not to actually use the data itself.
Okay, that makes sense. Thank you.
Thank you.
And so is the data itself then going to be completely open source, that everything that comes in real time is open source, or will it be processed and put into a database somewhere else that people can access?
Okay, that's a very good question. Like, we really hope to make it available in real time. That doesn't mean that we are going to say it's available in real time and spotless, so use it right now. The idea is to kind of show that it's possible to have real-time weather data in Africa, right? We will have quality control, and that's going to be a data set that we clean and publish. But like this is really an MVP, so they are kind of disturbing a bit the way people think, because usually if you want to get data about your own village, it will take years for that. So of course, real-time availability is a key component because that's how we imagine it and that's how data should be available. But that doesn't mean that this is the data people should use to fine-tune. We want to clean it and make sure that all stations are sending data properly. Like like yesterday I was just in a call with someone and they were telling me about this very expensive weather stations that were installed in Dakar. And after just a few weeks, they noticed that one of the stations was down. They went checking and they saw that actually ants were in the bucket. So they didn't allow the proper reading, and like there was an ant problem actually, and the station is still off because there is a debate on whether one should kill the ants or not. But it's really problems you would never expect.
Mm-hmm. Awesome. Any other questions from anybody? Okay, if not, thank you so much again, Sabrina. This has been really interesting. We're going to pass this on, and I hope that some people from UCT can get involved. But yeah, good luck with everything, and
thank you so much.
We'll keep in touch. Great stuff.
Thank you so much. Thanks, everyone.
Thank you very much.
Bye.
Bye for now.
Thank you. Bye.
Bye-bye.